Between 1 and 2 and problem 3. Here's the difference. What is the highest exponent you see on the top? Okay, what is the highest exponent you see on the bottom? Okay, so whenever, on the front side, by the way, flip to the front, real quick. I wrote down the rules there for you, but I'm just going to tell you. Okay, ready? Whenever the exponent on top is greater than the exponent on the bottom, whenever the exponent, the highest exponent on top is greater than the highest exponent on the bottom, you have no horizontal asymptote, but you have a slant asymptote. Just like we interchange the words, and I sometimes forget some of these, so you're going to fill it in. X-intercepts, real zeros, real roots, and solutions. Remember how we can interchange those? Yes? Yeah. Okay, depending on who writes the test, if it's ACT or SAT or unit test, there are two other words that may be interchangeable and mean the same thing. They could say slant asymptote, they could use the word diagonal asymptote, or they could use the word oblique asymptote. They all mean the same thing. And remember, this only occurs when the highest exponent on top is greater than the highest exponent on the bottom. And when that happens, there will never be a horizontal asymptote. So before we determine what the slant asymptote is, I'm going to come up to the top, and I'm going to look and say, okay, I know what the vertical asymptote is. If I take x minus 2 and I set it equal to 0, x equals 2. That is the vertical. And I'm going to graph it and get it out of the way. So I'm going to go to x equals 2 and make the dotted line. Okay, now slant asymptote. This is where I told you today to take a second piece of paper. Or I asked you today to do that at the beginning of class. So the top polynomial that you see is going to go on the inside. The bottom polynomial is going to go on the outside. You'll need room to do this, more room than is provided on the paper I gave you. Okay, so how do we do this? It's 4 steps. Just like when we practiced doing long division with 76 divided by 3 or whatever example I gave you. Here's how this works. I'm going to go over these 4 steps. Here we go. Please underline the first term on the outside and the first term on the inside. When I teach this, and it's not required, but I like to make little dotted lines, and these represent 3 different columns. Everything in this column will have an x squared. Everything in this column will have an x. Everything in this column will only have constants. For me, that's an easier way to start. Okay, so please don't yell at the answer if you know it right away so everybody can think. 1x times what would equal 1x squared? 1x times what would equal 1x squared? Can anybody tell me? X. Now, which column only contains x's? The first, the middle, or the last? Okay, put an x. That's step 1. Step 1 is always find out what you're going to top. Step 2 is distribute. So I'm going to distribute in this way. I'm going to take x times this, write it down, and x times this and write it down. Here we go. X times 1x is 1x squared. X times negative 2 is negative 2x. That's step 2. Step 1, distribute step 2. Step 3 is the easiest. Go to the second line, and whatever the sign was, change it. Step 3 is combine. A positive 1x squared and a negative 1x squared cancel. And when I combine negative 3x and positive 2x, I get negative 1x. And bring down the last term. Okay, underline the negative 1x. I'm going to go through the 4 steps again. 1x, wait with your answer for a second. 1x times what value would equal negative 1x? 1x times what value would equal negative 1x? Anybody? Okay, put a negative 1 here. So that's step 1, what goes on top. Step 2 is I'm going to take this value and I'm going to distribute it to both. So negative 1 times 1x is negative 1x. Negative 1 times negative 2 is positive 2. Line underneath. Step 3 is always change the sign in the second row. So it was negative, make it positive. It was positive, make it negative. And now I'm going to combine. Negative 1x and positive 1x cancel, and you can see that's what should happen every time. And negative 2 and negative 2 is negative 4. Do you remember back to elementary when you used to put like an R here? Yeah. Does everybody remember that? You put capital R and tell me that you do like remainder negative 4. Remember that? Okay, so here's the really official way to write this, and then I'll tell you how you can actually just write it in my class. The official way is y equals x minus 1, but we don't put an R anymore. This value is negative 4, and it's the remainder. We write it over whatever is off to the side. This is the official slant asymptote, but we're not going to get this exact with the remainder, so we're just going to write y equals x minus 1. So this is what I prefer, but if you write the official one, obviously I'm not going to count it wrong. Go into the place on the worksheet where it says slant asymptote and write y equals x minus 1. Okay, now we're going to graph it. So find negative 1 on the y-axis and make a dot. The slope is 1 over 1, up 1 over 1, up 1 over 1, and so on. Then I'm going to take a highlighter, and I'm going to continue that. So just like the previous problem where we had 4, we'll call them 4 rectangles or 4 squares, I have 4 sections, they're just not equal in size. So I know this. If I have something in this section, where will the next section have something? Kitty corner to it. If there's something up here, where will the next one be? Down here. Does that make sense? So they'll be here and here, or it'll be here and here. We don't know yet. Okay, we can figure out the real roots. The real roots come from the numerator. The real roots come from setting the numerator equal to 0. Okay, you're going to turn to your partner because this is actually more difficult than you think. Can you think of 2 numbers, because I want to see can I factor and solve. Can you think of 2 numbers that multiply to equal negative 2 and combine to equal negative 3? You have 10 seconds with your partner. Go. 5 seconds. Okay, who can think of two numbers? Is it possible to think of 2 numbers that multiply to give you negative 2 and combine to give you negative 3? No. Okay, so it's not factorable. Doesn't mean there's not an answer. Here's what we get to do. We get to cheat. When you can't factor and solve, I'm going to start cheating, telling you now how to cheat. Go to y equals. Clear up anything that's there. I'm typing in the numerator. Because I could not factor and solve it, I'm going to use a graphing calculator, and I'm going to find out what are the solutions, the x-intercepts, the real roots. Okay, so once you plug in just the numerator, hit graph. And I'm going to round my answer to the nearest tenth. I want to find out what is this value and what is this value. So here's how you do it. You ready? Please follow. Second, trace 0. When it says x-bound for this x-intercept, you have to go somewhere above the x-axis and then press enter. Directions say left or right bound, go somewhere below the x-axis, press enter, then go over the top of the x-axis and press enter once again. If we round this answer to the nearest tenth, it would be negative 0.6, right? So let's go over here and write, one of them is x equals negative 0.6. So I'm going to go, where is negative 0.6? It's right about here. Now let's find this one. Bless you. Second, trace 0. Use the arrows. Left bound in this case is below. So anywhere below, press enter. Right bound is above. Press enter. Go back over the top of the x-axis and press enter. Please make sure to help your partner right now if you are struggling with this. And the other 0 is approximately 3.6. So 1, 2, 3, 3.6. What does that tell us? Remember how I said that the function will either occur kitty corner in these 2 sections or these 2? Can everybody see that? Okay, it tells me it's in these 2. So from here, Let's get closer and closer to the vertical asymptote and closer to the slant. Closer and closer to the vertical, closer and closer to the slant. Okay. All right. Is there any limit how far down this will go? Now, I forgot to tell you something. Let's first do domain. Okay, so watch this. So I'm coming from the left. Even though it looks like it's going down, remember that's being pulled down and to the left at the same time. That's why it goes at an angle. So it's coming from the left. It keeps going up. It's going to the right as it goes up. It keeps going up as it goes to the right. And then it has a stopping point right here. It never crosses this line of 2. So it goes from negative infinity to 2 and stops. Can't go past x equals 2. Then it jumps over this imaginary wall and starts again. And it keeps going to the right with no limit. I want you to be really honest with me if you understand this range. So describing range right now. We know range describes the y-axis. I only want you to focus on this part and this part. Can everybody see those? Okay. When you'd be down at like negative 20, would you still see part of the function? Or does this function stop? It keeps going, right? So if I was at negative 20, would I still see it? If I was at negative 100, would I see it? Okay, so I'm always seeing it. I'm seeing it. I get up to negative 5. Do I see one of the functions? Remember, there's 2 parts there. Do I see them? Yeah. What about when I get up to 2? Do I see them still? Yeah. At 0, do I still see it? Yeah. What about at positive 2 or positive 5? Is there any area when I'm moving up where we don't see part of the graph? Yeah. There's nothing that stops it, right? Do you guys agree with me? Yeah. There's nothing that stops it. So the range is negative infinity to positive. As you go to the far left, it is headed down with no restrictions. As you go to the far right, it is headed up with no restrictions. Please go at this time down to number 5. Number 5 is most like the problem you will see on your exam for slant asymptotes. Okay, vertical asymptote, what makes the bottom equal to 0? X equals 2. Now, the highest exponent on top is a 2, the highest on the bottom is a 1. Since the degree on top is greater than the degree on the bottom, we can say there is no horizontal asymptote. But there is a slant asymptote. There is a slant asymptote. So how do we find out the slant asymptote? We take the top number and we write it inside, and the bottom number on the outside. Now what looks different about this compared to previous problems we have is normally there's more involved in the inside, right? So what's missing right now? What's missing on the inside that we normally see? We normally see just a number. What else do we normally see? An x. So is there any just x's, not x squared, but any just x's? No. Okay, we have to represent it with a 0x. You can't just leave it blank. And just like I heard somebody else say, there's no constants. There's no numbers by themselves. We have to represent it with a 0 again. If it doesn't occur, you have to put that place in there with the 0. Okay, I'm going to choose to make my little dotted lines. It's not required. Underline and underline. X times what is x squared? Okay, which area does it go in? First, middle, or last? That's step 1. Step 2 is to distribute this to both things outside. X times x is x squared. X times negative 2 is negative 2x. That's step 2. Step 3 is I go to the second line and I change the signs. If it was negative, it becomes positive, and vice versa. Okay, now I'm going to combine them. Cancels. I did it right. Combines to give you 2x and bring down the 0. Underline the 2x. x times what quantity equals 2x? Positive 2. That's step 1. Step 2 is I'm going to distribute 2x minus 4. Step 3 is I'm going to change the signs. Step 4 is I'm going to combine. So I am looking for y equals x plus 2. That's what I'm looking for. But you may see in upper level math, after you pass my class, you may see x plus 2, and there's a remainder of 4, so plus 4 over x minus 2. I would accept either one of these in this position, but I really do prefer the simpler of the two. Let's graph the two things we know. Let's go to x equals 2. And then I'm going to graph the slant asymptote y equals x plus 2. So I'm going to start at positive 2 and go up 1 over 1, up 1 over 1, and so on. As a reminder, when we graph this function, I'll either have a graph that curves across in these two positions or almost vertically up and down in these two positions. This is not perfectly vertical, otherwise it wouldn't be a function, but it's going to be kitty corner from one another. Okay, so we can do real zeros. Let's take this top number and let's set it equal to 0 and solve. We don't have to plug it into the calculator right now because we can do this mentally. Okay, ready? Let's solve for x. Take the square root of, get rid of the square. I'm going to square root both sides. This says there should be 2 answers, but the square root of 0 only has 1 answer, which is 0. So I'm going to go to 0 on the x-axis and make a dot. This already tells me that my answers are going to occur in these two areas. So we're doing a rough sketch right now. We'll use a calculator to be more exact a little bit later when we answer questions. This arrow that is going diagonal means it's being pulled to the left as it's being pulled down. That's why it's going down at a diagonal position. Is there any limit how far it's going to go to the left? So it comes from the left, it keeps coming until it gets to what wall? 2. Then it jumps over and it goes from 2 to positive infinity. Oh, I put it in the wrong area. This is x equals 0, negative infinity to 2, and 2 to positive infinity. Now the range is a little more difficult, and here's why. Do you agree we just approximated where this was? So here's why we're going to use the calculator in just a second. So I'm coming up from the bottom, and I just approximated. I don't know. I know it goes through 0, 0, but it may have went through 0, 0 and goes a little bit further and then comes down. I'm not sure. I just did a rough sketch. So do me a favor. We're going to plug this in. Let's do 2nd plus 7, 1, 2. Go to y equals. First parenthesis is x squared divided by parenthesis x minus 2. Okay, I can tell right now that this area, and I'm going to check here, don't do this yet, but I'm going to check if I'm allowed to do the maximum here. Give me 1 second. Left bound, right bound. Okay, I am allowed to do the maximum here. Do me a favor, find the maximum of this point. So do left bound, right bound, and 0. This looks really crazy, but this right here and this is in scientific notation, and this is both 0, 0. Do it on your calculator and see if you get 0, 0. That's what this is rounded. Find the maximum of this point, please. Do you also get 0, 0 or not? Yeah. Yes? Okay. Now I want you to find the minimum of this point. Please do that for me. Second trace minimum I want you to jump up above, so use the arrow to jump up. Oh, can I not get up there? Maybe keep going to the right. Oh, I don't know if it's going to allow me to. There it is. Okay, so if you keep going to the right, you eventually can get there. So let's find what is the minimum. Bless you. Left bound, right bound, and I'm at point. So I have 4, 8, but I'd like you guys to check out if you get the same. So if I go over 4, 1, 2, 3, 4, and up 8, 1, 2, 3, 4, 5, 6, 7. This is the lowest point. Make a dot here just for ourselves to know. This is the lowest point actually. Even though I know I did the sketch, it's the lowest point. This is the highest point of this. If you're like, why does this matter, miss? Here's the reason it matters. When I do the range, there's no limit how far it goes, but there is a limit. How far up does it go? It goes up to what y value? What is this y value right here? Let's do it again. It comes from the bottom. It keeps coming up until it hits what y value and then doesn't go any further. 0. Okay, here we go. Negative infinity up to 0, and it touches at 0. It touches that point. Then there's all this dead space. What y value does it start at again? What y value? Starts at 8 and touches it, and then there's no limit how high it goes. Let's verbalize before we end. Let's verbalize the end behavior. As you go to the left, I guess I'll write it down. As we go to the left, the y value is headed down. And as you go to the right, the y value is headed up with no restrictions.